Good afternoon. My name is Tanmay Kayande, and for the last decade, I've been the trusted advisor for executives from startups to SMBs to enterprise scale organizations. I found patterns in the architecture of those that lead their field. I know because I've designed and developed their systems and processes using AI, platforms, models, and frameworks to positively affect billions of users, and now bring my insights to you. Welcome to session 7. Last session, we learned how to use step-back prompting to help the model access better information. Today, we're going to teach the model how to think more clearly, especially when it's faced with complex problems that require logic and reasoning to solve. We're going to teach it to show its work. By the end of this session, you'll be able to define chain of thought prompting. Secondly, explain the advantages and disadvantages of using this kind of technique. To get there, we're going to cover 3 key ideas: what chain of prompting is, how it improves the model's reasoning, and how it can be combined with the few-shot technique we learned previously. If you're following along with the white paper, this is between pages 29 to 31. So let's define our key term, chain of thought prompting. This is a technique for improving the reasoning capabilities of large language models by prompting them to generate intermediate reasoning steps. Instead of asking the model to just give you the final answer, you're asking it to explain how it got there. This process helps the model generate more accurate answers, and it's especially useful for complex tasks that require reasoning before responding. This technique has some significant advantages. First off, it's low effort and highly effective with standard off-the-shelf models. Secondly, it provides interpretability. That's you can see the exact reasoning steps the model followed, which helps you understand its logic and even debug where it went wrong if it makes a mistake. Finally, it appears to make your prompts more robust and perform more consistently even when you move between different versions of an LLM. However, there is a primary disadvantage. Because the model's response now includes the entire chain of thought, it generates more output tokens, and this means the predictions can cost more or take longer to generate. Finally, it's important to know that chain of thought can be made even more powerful when combined with few-shot prompting. You can provide an example of a complex problem and its step-by-step solution to better guide the model on a new task. Going beyond the white paper, here's a classic LLM weakness: complex analysis tasks. If you were looking at a CSAT data across a quarter and asked what's the main theme of this customer feedback, it's likely the model would summarize the text you had without necessarily filtering only on the feedback. But then the prompt is modified by adding one simple phrase: let's think step by step. The model then plans its approach and breaks the request into simpler pieces. Using few-shot makes this output even better. Let's imagine you're asking an LLM to solve a multi-step math problem, but it keeps giving you the wrong final answer. What's a simple phrase you could add to the prompt to improve accuracy? You could add, let's work through this step by step, or show your work, and this would force the model to break down the problem into smaller steps instead of jumping to the final calculation. The main thing to remember is that when you have a complex task that requires reasoning, instruct the model to think step by step, and this simple phrase forces the model to slow down and work through the logic, which dramatically increases the accuracy of its responses. Chain of thought is great at generating one logical path, but what if that path happens to be wrong? In our next session, we'll explore techniques that generate multiple reasoning paths and find the most consistent and reliable answer. That's what we're about to get into, self-consistency and tree of thoughts. Thank you. I'll see you then.